at this. I want to say, is it FUTMINNA? Okay, so can I call on FUTMINNA to do their presentation now?
Okay, please, let us get the criteria so that we'll be fair, so that you know exactly what we're looking at, you know. We'll be looking at your results, innovation. Okay, we'll be looking at the story. The text I said is not what we're looking at. We're looking at the clarity of your speech. How does it start? Then we're looking at your teamwork, the team spirit involved. So that is what I'm addressing. Then your achievement so far, and your plan. So these are the 4 areas we are judging. So get it correctly so that when you are doing your delivery, you fit in this factor in your speech, in your delivery, in whatever you want to tell us today in your presentation. I want to take it again. Clarity, teamwork, achievement, and plan. I hope it is clear. So we are starting with FUTMINNA, so you can do your presentation.
Answer. I am Hamotosha Aziz Atanda from Federal University of Technology, Mina, Department of Electronics Engineering.
Sir, my name is Anuma Omezapo from Federal University of Technology, Mina, from Chemical Engineering Department.
Dr. Musa Omare from Federal University of Technology, Mina, Department of Materials and Metallurgical Engineering. Yesterday, our project, which we announced yesterday, that our project is at 90%, that is at evening. Now, our project is to cover, or is to be able to serve the doings of the farmers, is to replace the farmers in the field of farming. Now, one of the concept we are putting inside this design is to see how it will be able to cover most of the inputs of the farmers manually. Now, this machine, we are designing it to be able to suit and replace the farmers completely. Now, we have started the designing, but we are still kind of expecting some components to finalize the process and some parts. And we have been working as a team. There is division of labor in our team. What we do is that every of us has a specific task that is focused on. I focus on the fabrication and assembly. This man here focused on the card work. Any design we want, he put it for us, we print or we fabricate. And this man here is the electronics person, is the one that carry out the configuration, how the machine is going to work, either by remote control or autonomously. Everything is the one doing the coding and every other thing that we need the machine to perform the task electrically. Now, so far in the project work, we said we're at 95% now, because there are still some other things we need to put on. So we are at 95% now, although we have been facing some challenges, which is, let me say, that one we have been repeating it several times, which is power. Because sometimes our work will go far and the light will just went off, we have to start over again. And other people are waiting to do printing also. So this has been what is putting us back, where we cannot get to where we wish to. And our plan is to see how we can meet up with the task, with the assembling of the machine within today and tomorrow. Want to see how we can assemble everything together so that we'll be able to like start seeing our performance and see where we can adjust before the final day.
My own part in this project is the electronic part, the configuration and the design of the transmission. Earlier, we were able to complete the programming yesterday and the configuration, and we put it into testing. That it definitely worked with the testing, although we cannot disclose that or bring out the equipment to test, but we've already made the testing yesterday and it's worked perfectly. So the running part now is just to assemble the body parts, like which is the laser machine is doing the body parts now. Although the challenge we are facing is still the power system. Actually, this morning something like that happened this morning. Like when the light chip off, the body part that we are printing now like got damaged, so we have to replace it. This morning we have to replace it.
Our plans for today is for us, after we've getting the laser cutting machine, after it has finished cutting our components, is for us to start the assembling. Then we'll take it outside for test running, while I'll do some little stimulation while they are test running the software to know where the possible errors could come out from. That's our plan for today, sir.
In your speech, you didn't tell us the project title. So what do you know? You just mention farming to replace the human aspect. I think there should be a name.
The title is a multi-purpose or a multitask. Let me say multitask farming machine. A multitask farming machine.
Hello, if I may ask, I think it's appropriate. Can you still recall what the challenge was, what you are expected to do? I know very well that they said farming robots, but there were some other aspects of that. So that we will know.
That exactly. We should tell you the kind of task is performed.
The challenge you were given, which you are performing on.
Okay, a farming robot.
There were other things. I know about security. I know about intruders, all those things. All the items that you need to inculcate, or rather that you need to allow your farming robot to perform. Like maybe if a grass cutter come in to eat your farm implement.
Yes, sir. So, in aspect of security, to protect the farmer that's why we make the machine a multi-purpose machine, whereas the farmer will not have to leave his own home to go to the farm anymore. He will stay at home, and the machine, while he's at home, the machine will perform the task, and that gives him a security purpose. Then, in the other aspect of, maybe if you think of an alternative where you have different tractors, this machine's car is one. It reduces the cost of having different tractors working in the farm for you. So it does all the tasks while you are at home, and when you are at home, we believe that will provide a safety. Then while the farm is at work, we actually have a feature in the machine that will serve as security purpose as well. But right now, we can't really say what it will be.
The security part is not like the machine have to carry some weapon. The security part is just to like serve or replace the farmer. Instead of the farmer being in the farm, the machine will be in the farm doing the job, while the farmer is at home, overseeing the movement or the affair of the machine in the farm. So that is the security part.
Sorry. concerning the security, concerning the security purpose also, like to scare away animal, bird, maybe they want to vandalize.
I actually don't want to disclose the future to.
This is one of the things that we actually don't want. That is why we just give you that title, multi-purpose, multiple tags. Now, as we begin to dispose, we know what we have been facing before this day. We know what we have been facing. There are so many of the mechanisms that we actually don't want to disclose, but it has been open and other things has been.
Okay. Amadu, ABU is your turn.
Good morning, sir. Panel of judges. I'm Ibrahim Bello from Ahmad Bello University Zaria. I major in electronics and telecommunications engineering. Presented to you this morning.
Department of Electronics and Telecommunication Engineering, Ahmad Bello University.
All right. So far so good in the project development. Some of the challenges that we had yesterday, we have overcome them with regards to our component. They've arrived and we have started our work. Just like I told you yesterday, we are around 70 to 80%, but for the arrival of the component, we have been able to go beyond the 80% mark. So the only issue now that we are having is the issue of 3D printing and laser cutting. So when that's done, we get to couple and assemble our systems together. So me, I'm working on the overall project. I'm the leader that's putting everything together, although I also serve as the person working on the Arduino board and other designs as well, while Stanley Obi is working on the general assembly and as well as the mechanisms of the component and other features, while Aminu Mode is working on the CAD designs. So
concerning the CAD designs, I've already done more than
I'm concentrating more on the programming aspect of some of the components, like for the farming robots, the movement of the farming robots. So we are working, and as at yesterday, at least, that was our challenge yesterday, but as at now, we've at least overcome that challenge in terms of the programming aspect, to program the servo motor and some of the tires, the wheel on the movement, whether moving forward or backward. We've overcome that challenge.
And aside from that, we have been having issues of systems. The system they give to us, some of the software they install on them are actually not working correctly. So, as for the purpose of our system, our robotic design, is to actually do different kind of tasks on the farm to prevent the farmer and as well make farming more realistic for people to do even without being on the farm, and as well upgrade the standard of living of the farmers. Then it's also geared towards improving how farmers do their work from an informal way. Even if it's a subsistence farming, we're actually planning on having a kind of support system to um, outline what and what the farmers need to do before they can be able to make use of our product, so that to at least migrate them from informal ways of farming to a more formal way, so that they can at least get more yield on their crop production or livestock as well. Our plan for today. Yes, our plan for today is to, although I'll try and see what I have to discuss with the person in charge of the laser cutting and 3D printing, because the queue there is so much. There need to be balance in the things that are printing. It's not that just only one thing will be printing. So I'll have that discussion so that we can as well share how we do our printing. So then after that, once we get those things that we need to print, we will try and make sure we fix all our assembly, we assemble all our components together, so as to, there's what we call looping in engineering. Once we put up your system together, there's always this saying that the first one doesn't work. So once we couple them together, we have to go through the process again. We have to go through the loop to make sure that we correct all those, we dot all the I's and cross all the T's.
So much question. Do you have any, like my colleague mentioned, projects?
For now, it seems every team are actually keeping privacy of what they are doing. So we actually need to follow suit, and that's an edge for the competition as well. So at the end of the day, we can do.
I want to ask, what is the progress of your work?
And the progress of our work, we are about 85% now. It is the delay that is making us not to enter the 90% phase. Once we get those things printed, we get to that 90%, and that within that 90%, what we mean by 90% is the final assembly. Then once we do the final assembly, the 10% is to actually use in carrying out testing, going through the loop again, find what you have done right, find what you have done wrong, and as well see if there can be improvement on the features, because those features are actually your selling point, what you have to tell the farmer in just 1 minute, that they will grab it, that okay, this is what I'm investing in.
Since we are looking at the final stage, that will give us the 100%. I don't.
Thanks, sir.
UNIUYO, eh? Okay. Yes, come here.
Good morning, everybody. My name is Jeremiah Mfonakpan from University of UNIUYO Mechanical Engineering.
Good morning, everyone. My name is John Chidiberi from University of UNIUYO, Department of Mechanical Engineering.
My name is Umana Daniel Peter from the prestigious University of UNIUYO, from the Department of Mechanical and Aerospace Engineering. I'm here to talk about our achievement so far. For achievement, as I spoke yesterday, we talked about gathering of materials. So for the materials, we've gone a long way. We've gotten the ones we ordered online, and we also, like we said, we are pulling out resources from different strands. The resources is that we are also going to the recycle part. We've gathered materials, like we went to a scrapyard to cannibalize this from a baby roller stuff. So we got these 4 of these, so that this will minimize cost, number one. It will also save the environment, because if this is thrown outside, the environment to pollute. So we are considering several factors, but based on that, we also went into more research into what we are doing, because we don't want to do just cutting and attaching. We went into research, we went into the ITU database as the International Telecommunication Union to see what is the best way of communicating with our system, and we found out that there are ways. I will not say it here, but for what we came out with LoRa. LoRa meaning long range.
long range. So long range is saying that we don't want a system where we'll be trying to communicate and it will not be giving us real-time information. Say we don't want our robots to bump into another person's farm, and that's a legal issue. You know, like I said, an engineer is everything. As engineers, we believe in a Latin legal magazine that says that fiat justitia ruacuelo, meaning even if heaven is falling, justice must prevail. So we don't want to come to that point. We have legal combat with anybody, and also our robot for security sake. We talk about farming. It will have alarm system to alert people, alert the farmer also. So for our plants for today goes as thus. We will be going down to the attachment point. For the Arduino programming, we are done with that. So, you know, we have, since we are doing this robot, we have other projects we are doing. We are doing on-site simultaneous operation. So we actually completed our lamp. This was given, so this is one of them. So we are still doing things based on our previous project and still running this. But for our percentage, we are 80% at this point. We are still moving because, you know, we don't want to be stagnated. There is death in stagnation and life in dynamism. So we are moving, always moving. So for our teamwork, this is our CAD expert here. Although we all have experience of CAD, but he is the strongest hand here. Then he is the CAM expert. He is also handling the 3D printing, the laser cutting. Then I serve as the code guy and the project manager. Permit me to say I'm the project manager, although I don't have a certificate for that. For this project, I'm the manager for it. So we will incorporate safety. We incorporate, like I talked about, we incorporate legal matters. As engineers, don't want to just depend on design. We incorporate legal matters, and we also incorporate the life of the farmers. So, our farming robot, what we are calling our farming robot, we call it UNIUYO farm. But actually, the project name is a typical seed planting farming robot. The reason being that we have reasons why we are going to see, because you know all crops are plants, but not all plants are crops. So because if a particular farming robot cannot plant everything, we have to tailor it to a particular thing. So we just went to see. It cannot plant sugarcane, it cannot plant banga, it cannot plant coconut. So that's how we dwell. So for our challenges, like I said, our challenges are called obstacles. We surmounted several of them. So now we thought an idea that we will be working in the night while other people walk towards the day. So in the night, that was a leverage. Yesterday we actually did our 3D printing without hassle. So we've crossed that obstacle. But for other ones, we don't have any seemingly impossible one for now. But if we have any, we'll consult the SMEs, the field experts, to give us that help. So thank you so much.
Okay, he has actually said everything I needed to say. However, the obstacles we faced yesterday were just technical issues in running programs and printing models, then trying to fit parts together. Those are just the little challenges, not really anything that has to do with physical challenges. Let me put it that way.
So we thank you for giving us audience. God bless you and God bless Nigeria. Thank you.
Thank you very much. Thank you very much from what you have discussed. Those materials you want to reuse, will they be compatible to your scale up? That is the size of what you are doing. That's one.
That is whatever we intend to use, we make sure we first use them on design. Once it's matched on design, you know it will work in reality.
Okay. Yeah. You told us about the obstacles. What is the alarm system going to do? Who is he going to be? The alarm system. What is going to be the function and to who?
Okay. Now, since it's a feedback mechanism, the alarm system will, in terms of any threat, it will, or uncertain event, it will send signal to because we don't want the farmer to come to the farm. Maybe at his closet, in his phone, maybe an alarm, a module in his house, it will trigger, call for help, say alarm, there's something happening in the farm. But however, this cannot dwell alone. You know, we have camera system all over the farm. As a farmer, we have camera system around the farm. Then our alarm system will help us to tell us that there is an intrusion. Maybe shouting intrusion alert, intrusion alert.
The legal system. But rather, you made mention of legal aspect.
Yes.
What are you trying to address when you think about the legality of whatever? How are you addressing it? And where is it going to? Is it on the animals or on the plant or on what?
Now the legal system in the sense that we don't want to encroach into an man's farm. Your robot, without having some functionality, may encroach. So that's why we don't want to, like I talked about the IT, we don't want to use some other way of communication which are poor. We're choosing the best way for ourselves. Like I said, we want to work in real time. For example, if I say a camera is sluggish, you know your WhatsApp call, internet, and your normal cellular call. The WhatsApp call will be sluggish and your cellular call will be fast. So we don't want to use a mechanism that will go with that way because it will not give us real-time information. See, our robot is coming, it may bump or already cross the boundary, but we want to use a real-time, like I talked about LoRa.
Is it right? We don't need all the information, so let's see what we can do. From what you said, it appears that your work is 100% completed.
No, sir. At this point, it's not 100%, 80%. So, like I said, it's sign ups. We have other projects we are working alongside, simultaneous operations. So, as we are doing this, because we have a final day, there will not be another day to come and continue your classwork. So, we are pushing them together to the forefront.
So, what other development plans do you have to contain your project? What other plans do you have?
Contain.
To contain your project, that is to finish your project.
Development plan, like we talked about, we said we've gotten all the parts ready, we've done our Arduino program ready. So today we'll be doing assembly in practical, so automatically, and testing. Thank you, sir.
So good. YABATECH, you can take your stand there.
My name is Momoy Moseli David, an electrical engineering student of Yaba College of Technology.
Good morning, sirs. My name is Dogban Makonjola, student of Yaba College of Technology, Department of Electrical Electronics.
Good morning, sir. My name is Olayinka Oyewole, a student of Yaba College of Technology, Department of Electrical and Electronics Engineering, sir. So concerning our progress on the project of which is a farming robot that can carry out farming activities and replace